All right, ready for this? We're going deep into the world of Wilhelm Conrad Röntgen.
The X-ray guy.
Exactly. The guy who basically gave us X-ray vision.
Yeah.
But here's the twist. This deep dive isn't just about, looking at broken bones.
Right.
We're going way beyond that.
Much deeper.
Yeah. We're going to explore how Röntgens work. And we're mainly using this essay by Jürgen Schneppert. It's called Wilhelm Conrad Röntgen. Entdecker der Röntgenstrahlen.
Catchy title.
Yeah, right? But anyway, Schneppert really digs into how Röntgen's work, his discoveries, didn't just, revolutionize medicine, but actually laid the groundwork for all this crazy quantum technology we're seeing pop up today.
Yeah, it's mind-blowing when you think about it.
Right. Most people, when they hear Röntgen, they think X-rays, hospitals, broken bones, all that.
Right.
But Schneppert, he really gets into how these discoveries had these, ripple effects that are still shaping the cutting edge of science today.
Yeah, it's pretty amazing.
Who would have thought that looking at bones would lead to things like quantum computers?
It's a wild ride for sure.
So let's start with Röntgen himself.
Okay.
Schneppert paints this picture of him as this guy who, he had some struggles early on in school,
Yeah, he did.
but he had this unstoppable passion for science.
Absolutely. Even getting his doctorate, that wasn't easy for him.
Really?
Yeah, he had some setbacks early on, but he didn't let that stop him.
That's pretty inspiring, actually.
Definitely. Especially for anyone listening who's ever felt like they weren't, good enough at science or whatever they're passionate about.
Right. Persistence pays off.
Big time.
So Röntgen, he perseveres, and he ends up landing a professorship at the University of Würzburg.
In Germany, yeah.
And that's where things get really interesting.
Buckle up.
Okay, so paint us a picture. It's 1895. Röntgen's in his lab, I'm imagining, beakers and wires everywhere.
Definitely lots of cool-looking scientific equipment.
What's he even working on?
He's working with a cathode ray tube.
Okay, what's that?
So basically, it's this sealed glass tube, and they suck out most of the air inside. And inside, you have these two electrodes.
Electrodes.
Yeah, metal pieces.
Uh-huh.
And when you apply a high voltage to them,
Uh.
electrons stream from one electrode to the other, creating this beam.
Interesting. So he's messing with this tube, and what happens?
Well, he notices something totally unexpected. There's this fluorescent screen nearby,
Okay.
and it starts glowing.
Glowing.
Yeah, even though it's shielded.
Wait, so there's something invisible coming from this tube,
Right.
and it's powerful enough to, pass through a shield and make this screen light up.
Exactly.
That's kind of creepy.
A little bit, yeah.
But also really, really cool.
Totally.
I mean, what's going on there?
That's the million-dollar question, right? And this is where Röntgen's genius really shines through.
Okay, how so?
Instead of just being like, oh, that's weird, and dismissing it, he's
Oh.
like, no, I need to figure this out. He starts meticulously studying this phenomenon, running experiments, taking notes.
So he's like a scientific detective.
Exactly. He's on the case.
And that's how he discovers X-rays, right?
Precisely. He called them X-rays because, well, X represented the unknown.
Makes sense.
Even he didn't fully understand what he had stumbled upon, but he knew it was big.
And then there's that iconic image that everyone's seen.
Oh, yeah. Schneppert describes it so well.
Röntgen takes an X-ray of his wife's hand,
Right.
and you can see her bones, even her ring, clear as day.
Kind of spooky, right?
Totally. But also, incredibly groundbreaking.
Absolutely. That image, when he published it in his first paper on X-rays, it just sent shockwaves through the scientific community.
I can imagine.
It was like, whoa, we can see inside the human body now. It demonstrated the incredible power of these invisible rays to reveal, the hidden structures of the world around us.
And Schneppert argues that this is just the beginning.
Oh, yeah, this is just the tip of the iceberg.
Okay, so we've got spooky hands and a whole lot of mystery.
And a whole lot more to uncover.
Where do we go from here?
Well, let's dive deeper into the impact of X-rays beyond just medicine. Because trust me, it gets even wilder.
Okay, I'm hooked. Let's do it.
You know, it's easy to get stuck on those early X-ray images.
Yeah, the spooky hands.
Exactly. But as Jürgen Schneppert emphasizes in his essay, the impact of X-rays goes way beyond just, revolutionizing medicine.
Oh, yeah, for sure. It's almost like Röntgen, without even realizing it, he kind of cracked open this door to a whole new understanding of the universe.
Right, and that's where things get really fascinating.
So how did X-rays change our view of, the atom?
Okay, so think about it. Back in the late 1800s, the atom was still this big mystery.
Right.
Scientists had this idea that the energy inside an atom was this like this blurry cloud.
Okay.
But then they started shining X-rays on different elements.
Okay.
And something incredible happened.
Right.
They saw that the X-rays were being absorbed and emitted at very specific energies.
Specific energies, what does that mean?
It's like each element had its own unique X-ray fingerprint.
Oh, interesting.
And those distinct energies were a huge clue.
Okay, what kind of clue?
It meant that the energy inside an atom wasn't continuous, but was actually organized into these discrete levels.
Discrete levels. What's that, like levels on a video game?
Kind of. Think of it like steps on a ladder.
Okay, I can picture that.
Each step represents a specific energy level that an electron can occupy within the atom.
Got it.
Electrons can jump between these levels, but they can't just hang out in between.
So they have to choose a step and stick to it.
Exactly.
That's so weird. It's like the atom was playing by a whole nother set of rules.
And that's exactly what was happening. This discovery completely upended the classical understanding of physics.
Wow. So Röntgen's X-rays basically led to a revolution in physics.
In a way, yes. And you know what? This is exactly the foundation that Max Planck needed for his groundbreaking quantum hypothesis.
Planck, the quantum guy.
The one and only?
Okay, remind me, what was his big idea again?
His idea was that energy comes in these tiny, indivisible packets called quanta.
Quanta, like little bundles of energy.
Precisely.
Okay, so let me get this straight. Röntgen discovers X-rays, which then lead to this huge revelation about how energy works at the atomic level, and that paves the way for quantum mechanics.
You got it. It's a chain reaction of scientific brilliance, and Schneeppert really captures that in his essay.
It's mind-blowing. It's like Röntgen set off this domino effect that's still unfolding today.
And those dominoes, they're things like X-ray crystallography.
X-ray crystallography. Okay, I've heard of it, but I have no idea what it is.
Schneeppert actually spends a lot of time on it.
So break it down for me. What is it?
It's a way for scientists to figure out the 3D structure of really complex molecules.
Like what kind of molecules?
Think DNA, proteins, the building blocks of life.
Wait, so you're telling me we can use X-rays to actually see the shape of these tiny molecules?
You got it. That's exactly what X-ray crystallography does.
But how? I mean, those molecules are way too small to see with a regular microscope, right?
Right, but here's how it works. You shine X-rays at a crystal of a molecule. Yeah, like a solid form of the molecule. And the X-rays scatter off the atoms in a specific pattern.
Okay.
And by analyzing that pattern, scientists can piece together the arrangement of atoms within the molecule.
So it's like solving a super complicated 3D puzzle.
Exactly, a molecular puzzle. And this technique, it's led to some of the biggest discoveries in biology.
What kind of discoveries?
Well, for example, Rosalind Franklin, remember her?
Yeah, the DNA lady.
Yeah, she took that famous photo 51 of DNA using X-ray diffraction.
That's right.
Her work was crucial for Watson and Crick's model of the double helix. And as Schneeppert points out, none of that would have been possible without Röntgen's discovery.
Wow, so Röntgen's work helped us unlock the secrets of DNA. That's huge.
It is, and it didn't stop there. X-ray technology kept evolving, leading to even more powerful tools like X-ray lasers.
X-ray lasers. Now,
Yes.
that sounds like something out of Star Wars.
I know, right? But they're real and they're amazing. X-ray lasers produce these incredibly intense, super short pulses of X-rays.
How short are we talking? Like milliseconds?
Yeah.
Nanoseconds?
Femtoseconds.
Femto what?
Femtoseconds. It's 1/4 of a second.
Well, my brain can't even process that. So what can we do with these super fast X-ray lasers?
We can study things that happen incredibly fast at the atomic level. Like, imagine watching atoms move in real time.
Really? We can do that now.
Pretty much. It's like having a high-speed camera for atoms. We can see them dancing around, forming bonds, breaking apart. It's revolutionized our understanding of how matter behaves at its most fundamental level.
That's incredible. And to think, it all started with Röntgen noticing a glowing screen in his lab.
It just goes to show sometimes the biggest breakthroughs come from the most unexpected places.
So we've gone from spooky hand X-rays to atomic movies in just a few minutes. What's next?
Well, remember, we're here to explore how all of this ties back to the world of quantum technology.
Right. Quantum computers, unhackable messages, all that stuff.
Exactly. And that's where things get really wild. Buckle up.
All right. So we've gone from Röntgen's lab back in 1895 to, like, watching atoms in action with X-ray lasers.
It's been quite a journey.
It really has. So where do we go from here?
Straight into the quantum realm. It's almost like Röntgen, without even knowing it, opened this portal to a whole new world of physics.
Okay. I like where this is going.
And today, scientists are using X-rays to explore some of the most mind-boggling phenomena in the universe, and Schneeppet really highlights this.
All right, lay it on me. What kind of quantum craziness are we talking about?
Well, for one thing, X-rays are playing a key role in the development of quantum computers.
Quantum computers. I always hear about those, but I'm not really sure I understand what they are.
Okay, well, imagine a computer that can solve problems that would take a classical computer, like the
Okay.
one you're using right now, billions of years to figure out.
That's insane.
That's the potential of quantum computers.
And X-rays are helping us build these supercomputers. How?
It all comes down to those weird quantum properties we were talking about before. Remember how electrons in an atom can only exist at specific energy levels?
Yeah, like those steps on a ladder.
Exactly. Well, in quantum materials, those energy levels get even weirder and more complex.
Okay.
And we can use X-rays to probe those energy landscapes and figure out how to, control the quantum behavior of these materials.
So it's like we're using X-rays to fine-tune those quantum properties to build the components for quantum computers.
You got it. It's a whole new level of precision and control, and it's opening up some incredible possibilities. Schneeppet even talks about the potential for X-rays in secure quantum communication.
Hold on, secure quantum communication. What is that? Like some kind of unhackable messaging system?
Exactly. One of the fundamental principles of quantum mechanics is that measuring a quantum system inevitably disturbs it.
Okay.
So if someone tries to eavesdrop on a quantum communication channel, they'll leave traces.
So it's like a built-in alarm system. If someone tries to peek at your message, they trip the alarm.
Precisely. And scientists are exploring ways to use X-rays to create these ultra-secure communication channels.
So in the future, our top secret messages might be encoded in X-rays. That's mind-blowing.
It really is. And to think, it all stems from Röntgen's discovery over a century ago.
Mm.
It just shows the ripple effects of those fundamental scientific breakthroughs.
It's amazing, right? It's like Röntgen gave us this incredible toolkit, and we're still discovering all the amazing things we can do with it.
Absolutely. And Schneeppet really drives home the point that Röntgen's legacy goes far beyond those early medical images. It's about pushing the boundaries of human knowledge and understanding.
I think that's a great place to wrap things up.
Yeah.
So the next time you see an X-ray, whether it's at the doctor's office or in a science textbook, remember you're looking at the legacy of a true scientific trailblazer, a guy who helped unlock the secrets of the quantum universe.
A legacy that continues to shape the world today and will undoubtedly continue to do so for centuries to come.
Couldn't have said it better myself. And for our listeners, if you're eager to learn more about Wilhelm Conrad Röntgen, his groundbreaking discoveries, and the incredible world of quantum technology, be sure to check out the show notes for links to Wilhelm Schneeppet's essay and other fascinating resources. Till next time, keep those minds curious and those imaginations firing.